In the field or on the job site, engines live in a hostile atmosphere of dirt, dust, sand, and chaff. Successful preventive maintenance starts with stopping these contaminants before they wear away power and profit. The more air you can put into an engine cylinder, the more power it develops. Traditionally, adding more air meant adding cubic inch displacement with a larger cylinder and piston, like this. But as power goes up, the size and weight of the engine finally becomes impractical. The modern way to add more air is to turbocharge the engine. A turbocharger is simply a blower that rams more air into the cylinder by compressing it. The more air is compressed, the hotter it becomes. On more powerful engines, we add an intercooler to cool the air. Now we can pack a tremendous volume of air into the cylinder without increasing engine size. A naturally aspirated engine consumes about 13,000 gallons of air for every gallon of fuel. A turbocharged engine uses even more air. And on more powerful intercooled engines, air consumption is still greater. The air we breathe is free, but the free air an engine breathes can be very costly. The more air an engine takes in, the more work the induction system must do to keep contaminants out. The typical modern air induction system, equipped with a dry air cleaner, is designed to provide air in the right quantity and quality. The system consists of the pre-screener and pre-cleaner. Intake air then moves to a primary element, usually the final barrier to particles not removed by pre-cleaning. Many induction systems include a safety element to prevent serious engine damage should the primary element fail. The system directs air to the intake manifold or turbocharger through pipes and connectors, which seal the clean processed air from dirty outside air. The equipment and its application influences the location of the point where air enters the intake system. When a vertical stack is used, it is positioned carefully to avoid drawing exhaust fumes and is protected from rain. The pre-screener is a simple device to prevent leaves, chaff, lint, and other large contaminants from entering the pre-cleaner and air cleaner. On a vertical stack, it's usually part of the pre-cleaner or rain cap. A pre-cleaner is required to filter out larger dirt particles before they reach the primary element. Otherwise, the primary would have to be unreasonably large in size, and it would require servicing too often. When the air intake is located under the hood, pre-screening of lint, chaff, and leaves is usually accomplished by the grill screen. It is important that this screen be in place at all times. Pre-cleaners mounted behind the grill screen may be an integral part of the air cleaner canister. Dirt separated by the pre-cleaner is discharged out a rubber unloader valve or trapped in a collector bowl, which is periodically emptied. This type directs the dust to the muffler, where it is expelled with the exhaust. Pre-cleaners will remove from 80 to 90% of all contaminants before they reach the primary element. But what gets by can rapidly destroy an engine unless it is completely eliminated. And this is what gets by the pre-cleaner: a fine powdery dust, very much like talcum powder. It feels smooth to the touch, but engines are machined to such close tolerances that these dust particles will destroy them. Now, mix a bit of this silken powder with some engine oil. It feels slick, almost like a lubricant. Now, let's rub the glass with a piece of metal. and see what happens. In just a few seconds, the erosive wear of that silken powder has already begun. And if this dust enters an engine, this is the result. Lost performance from a little dust, a little downtime that could be holding up other scheduled work, the costly man-hours of labor, the replacement parts, losses that could have and should have been prevented. That's why the primary element is so important. Here's how it works. The remaining dust from the pre-cleaner is removed as it travels through a replaceable paper cartridge. These pleats greatly increase its effective surface area. Frequently, a safety element is used in addition to the primary element. Its only function is to protect the engine if the primary element fails. However, because of its small size, it will clog rapidly. Never rely on the safety element to do the primary element's job. As dust is collected in the primary element, airflow to the engine is gradually restricted. This restriction indicator provides a visual indication that the filter element needs cleaning. Some restriction indicators actuate a warning light on the instrument panel to signal for servicing of the air cleaner. Dry element type air cleaners are growing in popularity because they're highly efficient, relatively small, lightweight, and because they can be mounted in any position. Now, let's discuss the oil bath cleaner. The oil bath air cleaner directs incoming air down through the center tube into the oil cup, then up through the filtering element and out to the intake manifold. Dust is trapped in the oil in both the cup and the filtering element. Dust in the filtering element is washed to the bottom of the cup. When the engine is running at slow speed, the oil is elevated only partway into the filter element. As the speed increases, it is elevated to its maximum. The oil bath cleaner is at maximum efficiency at rated engine speed only. The oil bath cleaner must be mounted in an upright position. If tilted too far, oil will be drawn into the engine. To clean an oil bath air cleaner, first remove the oil cup and pour the oil out. Then, clean the sediment from the bowl. If the fixed element becomes restricted and service is required, it must be removed. Clean it by soaking and flushing thoroughly in a solvent and blow it out with compressed air. Never use a steam cleaner. It will look clean on the surface, but instead of cleaning, the contaminants are driven deeper into the element. This creates a hidden sludge and restriction in the element center section. Inspect the center tube for any restrictions. Also, be sure there are no holes, loose joints, or restrictions in the ducting between the air cleaner and the intake manifold. Fill the oil cup exactly to the level line with the same quality and weight oil used in the engine. Never refill with used oil. Now, servicing the dry air cleaner. It's called for periodically in the operator's manual. Of course, the dustier the working environment, the more frequently inspection and service are required of the entire system. So let's talk about servicing the system, starting with the pre-cleaner. Some pre-cleaners have a clear plastic collecting bowl, so you can readily tell when it needs emptying. Allowing this pre-cleaner to become overloaded places a great burden on the primary element. If the dirt from the pre-cleaner is expelled by an unloader valve, the valve should be examined closely to make sure that dirt hasn't plugged the opening. Check for any tears or cracking and replace the valve if necessary. Some pre-cleaners have an aspirator which draws contaminants to the exhaust system, where they are expelled. This assembly needs occasional checking to assure that leaves or other debris aren't blocking the way. The aspirator consists of several spiral tubes called vortex generators installed in the air inlet. Notice that they protrude into the pre-cleaned air compartment. This compartment leads to the primary element. Air passing through the tubes is spun by the vortex generators, causing dirt particles to be thrown against the walls of the larger tubes and drawn off by the vacuum from the exhaust. Now, let's service the dry air cleaner. The heart of this air cleaner is its paper filter element. When it needs cleaning, follow the procedure outlined in the operator's manual. First, simply tap it with the hand while slowly rotating it. This will loosen the dust packed in the paper pleats. Never tap the filter on a hard surface. Here's what happens. The filter is so heavy with dust that banging it on a hard surface will break the paper element and allow dust to enter the engine. The second step is to blow out dust with compressed air. Direct, clean, dry air up and down the pleats, blowing from inside to outside. Use a low pressure, about 30 pounds per square inch. Keep dust from entering the inside of the element. For a completely thorough cleaning job, follow a third step. Use a non-sudsing detergent and soak the element. This step must be followed if the element is coated with soot. Never soak an element in fuel oil, gasoline, or solvent. Then, after soaking, use a tool such as this, designed to fit on the end of a water hose. Rinse from the inside out with clean water. Shake out the excess water and allow the element to air dry for at least 24 hours. Never install an element that is not completely dry. Moisture and dust form a muddy film on the element that restricts air movement. Following these steps, an element can be cleaned as many as 6 times before discarding. Many operators have a spare element to use while the other is being serviced. After checking for dents, nicks, or tears, check also for holes which could pass dust. Place a light bulb inside the element and look toward it from the outside. The smallest pinhole is reason enough to throw it away and install a new one. Finally, check the element seals to be sure they're reusable. Before reassembling the air cleaner, inspect the safety element in place for traces of dust. Unless there is evidence of a failure of the primary element, the safety element should not be removed except for its recommended annual replacement. At that time, don't attempt to clean it. Throw it away and install a new one. The air restriction indicator should be reset, if of the mechanical type, when the air cleaner is serviced. If the indicator doesn't work properly, replace it. Don't over-service a dry element air cleaner, only when the restriction indicator says to. Over-servicing exposes the induction system to possible contamination and the element to possible damage. If there's an occasion to disassemble the intake piping, check for evidence of dust entry at every point on the clean air side of the system. Every connection must be dust tight. The clean air side of the intake system should be checked regularly for leaks. If they should go undetected, serious damage will occur without prior warning. Beware of a damaged element, a loose or torn seal, improper element seating, loose connections or clamping at hose or pipe joints, hardened or cracked flexible connectors, cracked or worn spots in steel pipes, or a damaged or missing restriction indicator device. We've seen what happens on the clean air side of the system from undetected leaks or a failure of the air cleaner. Engine failures, a direct result of worn parts. But suppose the elements in pre-cleaner are doing their job. If you fail to service them, whenever servicing is indicated, the engine can still be damaged. As the particles begin to cause excessive restriction, a loss of power isn't immediately noticed, particularly if the engine is turbocharged. However, fuel consumption will increase, demanding additional air from the turbocharger. There will be a dangerous rise in cylinder and exhaust temperatures. Oil consumption will occur. The result? Damage to pistons, rings, valves, even the turbocharger itself. Repairs can cost plenty. Lost production due to downtime costs even more. Performance and power, designed and built into every engine. Proper preventive maintenance of the air induction system will assure clean air that engines may live to perform demanded applications.